First, I'm now master's second year in the Faculty of Agriculture in Kyushu University. Personally, recently I'm really getting into playing billiard in Chikuzen Maibaru, next to Kyushu University. And also, I've lived in several countries, just like Shanghai in China, Illinois in US last year, and also Cameroon. So yeah, I'm also excited to talk about this country's episode. From now, yeah, I would like to talk about today's theme. Climate change directly impacts on the food production, just like rising temperature strongly affects for the rice production. Most of you know that. But how do the scientists predict the exact future effect of climate change? In our laboratory, we mainly progress our research through three ways. One of the ways is interviewing with local farmers in Itoshima, and also building mathematical crop models. And the third way is doing rigorous evaluation through eating and drinking. First, about interviewing local farmers. From my perspective, rigorous evaluation of exact effect of climate change through data analysis and using data is probably impossible, I guess. So our laboratory finds the exact problem or the scientific questions through interviewing with local farmers in Itoshima. So the interview will provide insights into sustainable agriculture under changing climate. For example, my lab members found the research questions through the interview with lemon farmers in Itoshima, and she finally published the paper based on the interviewing with local farmers. And the next way is building process-based crop response models. It is not just like the equations. Especially for example, in order to evaluate the effect of climate change, focusing on sustainable irrigation, which the scale is more than 50 hectares. We sometimes use the mathematical models, focusing on stomata. This stomata is like the mouth of the plant. The size is less than 0.1 millimeters. And also, we research the mathematical model focusing on the leaf transpiration. It is like the water used from the leaf. This model is this phenomenon is also so small. The size is less than 1 meter. So our laboratory also mainly progress our research using the mathematical models, focusing on so tiny scale for solving so huge scale problem. The final way of progressing the research in my laboratory is evaluating the effect by eating and drinking. Most of you like drinking wine, right? The wine is made of grape. Also, grape is also affected by climate change, just like rising temperature. For example, rising temperature affects the sugar accumulation and also water stress. So drinking wine is not only just enjoying, but also one of the effective way of detecting the exact climate change, just like rising temperature. So far, I introduced mainly 3 ways of progressing research in my field, like food production and climate change. From now, I would like to introduce my research field, focusing on building crop models. I mainly use the stomata model and also translation model. This translation is big scale for solving the problem of sustainable irrigation, which the size is so huge. Actually, the mathematical model of stomata and translation is a little bit complicated. Like the example 1 and the example 2. And moreover, rigorous model parameter identification is required for getting such model parameter. Yeah, however, in order to get such model parameters, we mainly do the kinds of rigorous experiment using specific equipment and environment. Using just like the machines in the certain specific environment. Actually, successfully identifying and obtaining such model parameter needs mainly 3 key resources. Firstly, we need so huge financial investment. Actually, I went to US last year and did such experiment. The laboratory in US prepared for more than several $1 million only for getting such model parameters. And also, accessing to specialized experimental facility is needed, and collaboration with numerous specialists, including professors, other scientists, is also needed. So, like progressing research with getting such model parameters every time is taking so much effort, and sometimes it's unrealistic. So, in our field, we recently collaborated with computer science field. Especially, we recently started to use machine learning models for obtaining such model parameters without the need for such rigorous parameter identification. Like in my experiment, I built a weather station to get such temperature, precipitation, and solar radiation, and the cost of weather station is like super cheaper than such a rigorous experiment and then I entered such information into AI model, and then predicted the model parameters such as stomata and also translation in leaf scale. Especially my research term is using such meteorological knowledge and also computer science knowledge for solving the problem of sustainable irrigation, especially focusing on corn production. So I firstly built the weather station in order to get such weather information, and also I inputted machine learning model. I inputted such information into machine learning model, and then predicted the canopy scale of transpiration, and also evaluating the accuracy. Last year, I went to US, especially I went to University of Illinois, nearby Chicago, mainly for progress in my research project. This is the center picture is a scenery of doing such experiment in the corn field. And the most impressive memory for me is like I always moved into the single cone field using this compact car because the field is so wide that like I can't move in my foot. And the scenery is like this. As you know, we cannot see the limit of the scenery. Yeah, everywhere is cornfield. Like, especially in summertime. Summertime is one of the. Summertime is mainly like. In summertime, we mainly growing corn from May to October. In summertime, I remembered I spent more time with corn than other people in US. So far, I introduced my research schema, like the predicting evapotranspiration for solving the problem of sustainable irrigation. So my research will connected to achieving one big goal. The goal is sustainable corn production. And in order to achieve such goal, like as I mentioned before, one of the effective way is combining various knowledge combining various knowledge from coming from completely different fields, just like physiology, meteorology, hydrology, and also information science. Yeah, this is the main message for me about the new view of climate change in this presentation. By the way, my personal motivation for progress in my research is imagine the connection of my research and sustainable corn production, and then connecting to the sustainable tacos production. Maybe all of you had various interests and hobbies, and maybe some interests and hobbies will be affected by climate change. So I would like to conclude my presentation using the message like it's about time for you guys to connect with your interest and climate change. That's all.
Thank you very much. I think we have the time. So yeah. Okay, yeah, go ahead.
Okay, let's go.
Very interesting presentation, but I'm wondering why corn? Is there something about it that makes it particularly suitable for research, or because of tacos, or why?
One of the reasons is for tacos, but also actually like the mechanistic model about example 1 and example 2 is mainly focusing on corn, corn. So and also like such type of equation for corn is more complicated than other species. So I felt such motivation for for progressing the research, focusing on such complicated models.
So you actually chose a complicated research subject.
Yeah, and also for tacos.
Thank you.
But the machine learning model, what do you compare your predictions to?
I compared to the information for the answer. This information is measured by the such cone field. So I compared with such predicted values and the measurement values.
How do you measure these things in the field?
For me, I measured the energy flow in the cone field, and also estimated the evapotranspiration. So I didn't measure the exact water and exact the amount of water used, but I measured through using such energy cycle. Thank you so much.
It's a little bit related to that question. So if the measurement is to check that the model is accurate, is that right?
Yeah.
Okay. So I'm interested also in the ML model and the mathematical model. So is the ML model produced here in Kyudo, or where do you get the AI model from? You making it yourself?
That is the knowledge in my laboratories.
Oh, really?
Yes.
Oh, so it's produced here. So it's quite expensive to make ML models, right? So I'm guessing it must be cheaper than the mathematical one.
Actually, I use the ML model, which the cost is so cheap.
Oh, really?
Yeah, I use Python for managing managing AI models. So we didn't take so much cost for creating such ML models and also process model.
Did you compare the ML model and the mathematical model to see if they're both the same level of accuracy?
I also use the mathematical model, for predicting the evapotranspiration. In my comparison, the accuracy of ML model is greater than the accuracy in process model. Yeah.
So it's cheaper and better.
Yeah.
I have one comment, one very quick question, and one longer question.
Okay, got it.
So the comment is, I think you do corn because there's a lot of it in Illinois, right?
Yes.
And so thinking of a lot of it in Illinois, can you distill something from it, like have corn shochu?
Corn shochu. Actually, I'm also interested in drinking corn shochu, just like whiskey, right?
Bourbon.
Yeah.
Part of them. Okay, part. Okay, that's good. And a more serious question. The word sustainable is sort of always tricky.
Yeah.
And what you mean by sustainable. And so I'll give a little bit of background before I want to hear your thoughts. But sort of sustainable, one way of thinking of it is that you try to keep something going. The other is to try to think in terms of bigger goals, like health and well-being, and then try to see what would be sustainable in terms of health and well-being, and what you need to achieve then for corn. And for instance, one question is how much corn do we need in Japan, and what would be optimal, or also thinking larger picture in terms of economics. What's the place of the corn? And I got really interested in this topic of defining sustainability goals more carefully, in part also with, so after reading, I don't know if you know the work by Saito Kohei, it's a Japanese philosopher, economist. He talks about degrowth Marxism, and he says he's very against the whole idea of sustainability, and he thinks that sustainability will be the ruin of the world, basically. And sometimes to have proper health and well-being, maybe we should consume less, or we should consume differently, or we should think about the package. And so I guess this big cloud of many big questions. How do you see sustainability in your case? And so, are you really looking only at the corn, and how are you trying to think about sustainability with the corn? Is it maintaining it, or increasing it, or what's your idea?
For me, firstly, personally, I cannot imagine the big picture for the sustainable goal for precisely, but from my perspective, achieving the goal of sustainable irrigation, especially in US, at least US is one of the major fields for corn production. So firstly, I'd like to contribute to sustainable irrigation for corn, and then if such a small goal like the sustainable irrigation for corn is achieved, this achievement will be will affect for the various fields, not only agriculture but also such as industrial fields. For example, field scale optimizing field scale evapotranspiration is one of the will connected to the field scale water cycle, and such industry is also one of the component of field scale water cycle, and if the water cycle in agricultural field is achieved, maybe the positive effect for it is will affect for such other fields, just like the reducing the amount of water used in the factories. So for now, this opinion is the big goal for me. And
I agree. It's a good place to start. So improve the efficiency of the production. But that still leaves the question, how much do we want of it? And I think in some sense, and that becomes a bigger, almost like a health and well-being question. And in One Health, for instance, we would say maybe we should eat less beef and more corn. Or instead of eating corn-fed beef, just feeding ourselves on it. This corn is not only using for human but also using for such cows and pigs, and most of us always eat such products. So I hope improving such technologies in corn field will connect it to the big goal, just like the health. I have a totally different question.
Okay, got it.
A technical question, maybe you're happy with that. And so you mentioned you're looking for the parameters, right?
Yes.
And I'm thinking if you really want to have sustainable sort of production, maybe I think having an exact best parameter may be not ideal, because sometimes you need noise, you need variation, and better growth, better corn might be corn that is resilient and can deal with noise or can adapt. So basically, are your optimal parameters, are they points or are they ranges?
Actually, I mainly use machine learning models, and I also use the process model, just like a process model, which is required for optimal parameters. in my research, like we decided the optimal situation between environmental conditions and the evapotranspiration.
I guess what I'm trying to say is that if you do ML on that,
Yes.
maybe it pumps out exact parameters, and maybe that is not the best.
Yes.
And maybe you need some level of variation. So can you get that out of your models?
Yeah. Yeah. Honestly, yeah, it is a little bit difficult question for me, but.
I'm sorry.
We finally we mainly focusing on the accuracy of predicting evolutionary situation, and we cannot represent whole process. We cannot clarify the whole process of learning process when the machine learning model is included. So that's why I cannot mention the detailed.
No, I think the way you go about it is really good. The only thing I worry is that this approach will lead to single optimal parameters.
Yes.
And in reality, maybe you need some noise or
Yeah.
Well, it's just something to think about.
Okay, got it. Yeah, actually, I also got the measurement data of evapotranspiration through predicting using the energy balance. So
maybe to give a very simple example, I used to water. We have a pine tree at home.
Oh, really?
Which is just gajarit because my wife's name is Pine Tree. Pine Tree Hill. So I used to water it every day, and I was not the best. And so then now I water it on purpose very irregularly. And so I do it.
Okay.
Sometimes I give it a lot, and sometimes nothing for 2 weeks in the middle of summer, and it's happy with that. And so I think somehow, maybe we should worry less about optimal parameters and more about optimal experience and or stimulation. And that's sometimes it's like with for human beings as well. I think if you're always raised in clean environments, you're going to be very weak. But if you learn to deal with many different kinds of experiences, get exposed to lots of dirt and noise, you'll be stronger for it. So maybe you need to tease your corn a little bit.
Yeah, exactly. Yeah, for me, we mainly, at least it was not connected to your questions actually. We mainly grow corns, mainly for feeding for cows and pigs. The majority of corn is just like this. So and such corn is quite hard for biting. So for me, the way of
really tough corn that only the beef,
yeah,
only the cows will eat.
Yeah. Anyway, yeah. Thank you so much for your questions and comments.
Great. Yeah.
We
Great.
got for one more question, if anybody's got one. Just last day you were in Illinois for a long time. What was the best corn-based food you had? That's not tacos.
Oh, really? For me, the best food in US using corn is it's it's so popular snacks. I forgot the name. The car.
Sorry. Nachos?
Yeah, nachos. Yeah. Yeah, I sometimes eat it with dipping some sauce. So yeah. Yeah, thank you so much.
All right, yeah, please give another round of applause.